Hey guys, this is Miss Figueroa. Sorry I had to make a second video. It's just I have a 15-minute max for the time. So, in this last example is on page 31 on Unit 2 exercises. It has a part A and a part B, but I wanted to add this part to it because this is on the response question on the test tomorrow. So, cordless phones in their October 2003 issue Consumer Reports evaluated the prices and performance of 23 models of cordless phones. Computer output gives these summaries for the prices. So this data specifically is for prices of phones. So in context, this 15 really means the cheapest phone was $15. And then the max 200, mid-range, we don't really need the mid-range. And then we have the mean. And to be honest, I really don't even know what TR mean stands for. And the standard deviation is at the end. So the question here says, suppose we evaluate the price and performance of an additional phone for $90. So I am going to add an additional phone for $90, and then we're asked to find what effect will including this phone have on the mean and standard deviation, and you need to explain. So the best way I think you can understand this is to actually make a box plot to see the data visually. So in order to do the box plot, first we need to calculate the fences. So the lower fences, in order to do that, you need to find the IQR. So IQR ends up being 110 minus 30, ends up being 80. And then you multiply by 1.5, and that is going to end up being 120. So the lower fence is Q1 minus 120, so it would be 30 minus 120 would give you negative 90. And then the upper fence is Q3 plus 1.5 times IQR, which ends up being 120. So Q3, which is 110 plus 120, that will be 230. So you can see my max is 200, so that's before 230, so it's not an outlier. Negative 90. 15 is not an outlier. So I don't have any outliers, so we'll make a box plot. In your number line, I would go by tens maybe. My number line is too high. Let me move my number line to the bottom a little bit. Okay, and I'm just going to go by tens. So here's my 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, 150, 160, 170, 180, 190, and 200. So I don't have any outliers, so my minimum is at 15. That's going to be between 10 and 20. Around here, Q1 is 30, which is here. And then I have median is at 50. And then my Q3 is at 110. So you can see my data is pretty spread apart. And then my maximum is all the way out here at 200. So I'm going to make my whisker go all the way over there. Okay, so visually you can see the data is very spread apart because it's from 15 all the way to 200. That's a pretty big range, so your data is like all over the place, which you can see in the standard deviation. The standard deviation ends up being 52.08. That is a huge number for standard deviation, so your data is very spread apart. Excuse me. So then the question is, if I add an additional phone for $90, think about where on the box plot would 90 fit. So 90 is somewhere right here, right? So if I add a phone right here for $90, that's actually, remember what's inside the box, that's the majority of your data. So the $90 lies within the inside of the majority of the data. So specifically, how does it affect the mean? If you look at the actual mean though, 71.75, that $90 is actually bigger than the 71.75. So then I would then say the mean maybe I should type it out as text box. So let me stop my pen. I'm going to add a text instead. Whoops. It's not going to let me add it on here. It's going to move. Oh, okay, it didn't move that. So I'll just add it here. So, the mean would slightly increase because the phone for $90 is bigger than the current mean of, what was the value, 71.75. Okay, so the mean would actually increase because that $90 is bigger than the 71.75. So you're adding a bigger value, so your mean would increase. Now, for the standard deviation, remember, it measures on average how far away your data is from the mean. So on average, your data are about 52 units away from the mean. So that is a pretty big difference. So if you look at the comparison 90 to 71, that's about 20-ish units away from the mean, which is smaller than the actual standard deviation of 52. So then, therefore, the standard deviation is going to decrease because you're adding a value that's closer to the mean in respect to the standard deviation. So that's what you would write out. We would say the standard deviation will slightly decrease since this new data, or this new phone, because you want to add context, this new phone for $90 is fairly close to the mean in comparison to the standard deviation. Deviation of, what is it, 52.08. So again, the standard deviation will slightly decrease because you're adding that 90, and 90 is about 20 units away from the mean, and standard deviation is 52. So on average, your values are about 52 units away from the mean. And because the 90 is closer to the mean than the standard deviation's distance, then the standard deviation is slightly going to decrease. Because again, the $90 is fairly close to the mean in comparison to the standard deviation of $52.08. So I hope that kind of makes sense. One more time, the mean is going to increase because you're adding a value that's bigger than the mean, and then the standard deviation is going to slightly decrease because standard deviation measures the average distance from the mean. So on average, your values should be about 52 units away from 71. And 90 is only about 20 units away from the mean, which is smaller than the standard deviation. So it's going to actually decrease the standard deviation. Okay, I hope that makes sense. Again, this is going to be on the FRQ response portion of your test tomorrow, so make sure you understand this. Hopefully you pause the video now and then try to do the example on your own to try to see if you actually understood the concept. All right, see you guys tomorrow.